In this video, we are going to solve question number 5 of Pure Mathematics 1, January 2021. Question is figure 3 shows the plan view of a viewing platform at a tourist site. The shape of the viewing platform consists of a sector A, B, C, O, A of a circle, center O joined to a triangle AOD. Given that OA is equal to OC is 6 meter, this OA and OC is given is 6 meter, while AD is 14 meter. This AD is 14 meter. Angle ADC is 0.43 radians. This angle is given in radian, so make sure your calculation should be in radian meters. Your calculator must be in radian. And angle AOD is an obtuse angle. This angle AOD is obtuse angle, is more than 90 degree if we take in degree meters. So if we have to convert it into radian meter, then we will do the question. Let's see how we will do it. So in the part A, we have to find the size of angle AOD in radian to 3 decimal places. So to find this angle AOD, I will consider this triangle AOD and will use sine rule for that. So let's draw this triangle. This is triangle AOD. This one we know is 14 meter. This angle is 0.43 radian. This is 6 meter. So if I use sine rule, I have to find this angle AOD. So I can write this side divided by sine of this angle will be equal to this side divided by sine of this angle. So will be 14 over sine of angle AOD will be equal to 6 over sine of 0.43 radian. I can write from here, if I will cross multiply, cross multiplication will give me 6 times sine of AOD equals 14 times sine of 0.43. Shift 6 to the other side, sine of AOD will be equal to 14 times sine of 0.43 over 6. Now, angle AOD will be, if I have to find this AOD, so shift sine to the other side, it will become sine inverse 14 times sine of 0.43 over 6. Now let's use the calculator to find this value. Make sure your calculator should be in the radian meters. I will change it into radian meters. So sine inverse 14 times sine of 0.43 divided by 6 will give 1.3365. 1.3365. If I will round it to 3 significant figures, so it will be 1.337. But the calculator, whenever we will calculate with the calculator directly, so it will give us acute angle. Now to find the obtuse angle, we know that to get an obtuse angle, it is, if it's in degree, it is 180 degree minus acute angle. But right now we are doing the radian measure calculation. So 180 degree is equal to pi radian. So it means to get the obtuse AOD, it will be pi minus this acute angle, which is 1.337. So now calculate it. Pi minus 1.337. So will be 1.8045. But final answer should be to 3 decimal places, as the question is saying write to 3 decimal places. So writing to 3 decimal places, it will be 1.805 radian. This is our obtuse angle AOD. Now part B is the length of the arc. You have to find the length of arc ABC in meters to 1 decimal place. We need to find the length of this arc ABC in meters. So for that we need this angle. We know this angle already in the previous part we calculated. So this angle will be 2 pi minus this radian angle that we found here, 1.805 radian. I'll write it 1.805 radian. That is the central angle. So then using this formula, S is equal to r theta. R is this radius already, 6. We are having this. So we can find this. So let's do it. Use S is equal to r theta. R is 6 times theta is 2 pi minus this 1.805. Calculating this one, 6 times 2 pi minus 1.805 will be 26.869. This is equal to 26.869. But we have to write our final answer to 1 decimal place only. Let's see, it is to 1 decimal place only. So S will be equal to 26.9 meters. Then part C is the total area of the Vane platform in meters squared to 1 decimal place. So we need to find the total area of this platform. Now to get the total area of this platform, we know that this angle is 1.805. This is a sector. If I consider this is sector, so area of sector we can use in radian measure. The formula is 1/2 r square theta. And for this triangle, we can use the triangle rule. We need to get this angle first. If we will get this angle, then using this formula 1/2, the multiplication of these two sides, this 6 times this angle. So first find this angle. To get this angle, keep in mind, we know that the sum of 3 angles in a triangle is 180 degree or pi radian. So we are doing the radian measure calculation now. So that is why this angle will be, if I have to find this angle is going to be pi minus this 1.805 plus 0.43. So that will be our central angle in the radian measures. So pi minus 1.805 plus 0.43. That will be 0.907. You can write to 3 significant because 0.907. So this angle is 0.907 radian. So now we can find the area of whole sector. So area of this platform in meter square, if we have to find, so will be area of platform will be equal to 1/2 r square theta plus 1/2 times 6 times 14 sine of angle between these two sides. Because we are finding the area of this triangle, so I'm using this formula. If we have a triangle, let's suppose this is a triangle whose sides are A, B, C. If we know this angle, let's suppose this angle is theta, so we can write this 1/2 AB sine of theta. So I use this formula here. So using this one, it will be sine of 0.907. So 1 over 2 r, the radius is 6, so 6 square into theta. The central angle for this sector was 2 pi minus 1.805 plus 1 over 2 times 6 times 14 times sine of 0.907. So calculating this one, it will be 1 over 2 means 0.5. So 0.5 multiply 6 square times 2 pi minus 1.805. Then plus 0.5 because 1 over 2 is 0.5 times 6 times 14 times sine of. Make sure your calculator should measure the angle in radian. Sine of 0.907. So that will be 113.689 meters square. So as no degree of accuracy is given in the question, no, it's to one decimal place. So that's why I round to one decimal place. Rounding to one decimal place, it will be 113.7 meters square. That is the end of this question.